Comments, questions, concerns. Ionic naming. We're feeling pretty good. Roman numerals, polyatomics, ides and eights and ites and eums and... Okay. Hearing nothing, I'm going to assume that we're good. Today is Wednesday, and I have not given you any sort of assessment since the beginning of the semester, aside from a lab activity and an assignment on Lewis and Bohr diagrams. So, this week, you should expect, not today, but at some point in the next 2 days, you should expect a quiz on things that we have covered. The longer the quiz takes, the more obviously I can put on it. But at some point, actually I'll go so far as to say at some point in the next 4 days, you're going to have 2 quizzes. I'll say that. I'm going to I'll quiz you on the Lewis and Bohr diagrams. Not today. And I'm going to give you a naming quiz once all the naming dust has settled. Yes, Evelyn. Next 4 school days. Obviously, I can't include Saturday or Sunday. I mean, I could theoretically hunt you all down on the weekend, but I don't want to spend my weekend doing that. That would be awful for everyone. Not my idea of a great weekend. Hunting down students to give them a science quiz. Okay, so last bit of naming. Covalent compounds. This is the one piece of naming that does not always show up in grade 9. Hands up if your Science 9 teacher got you guys to do covalent naming. Who did you have? Gil. Easton. Also Easton. Did you do this with Mr. Cabrandt? Okay. It doesn't always show up in 9. It's a natural extension of what we've done because, I mean, it's the other kind of compound. Ionic is when you've got a positive and a negative or a metal and a non-metal. It gets a little bit complicated now that we've got the polyatomics because ammonium is a positive ion, but it's not a metal. But when you've got ammonium and some negative ion, that thing's still going to be ionic. So we can't say metal, non-metal anymore. We're going to call it positive and negative ions. Covalent compounds, these are the other set. The only other set that bonds are the negative negatives, or in this case, the non-metal non-metals. So covalent compounds are all non-metal non-metal. How is this light blue? Can we read the light blue way out back there? We can see it in the back corner. Okay. So this is non-metal non-metal. Or, I'll just put a minus sign. Negative, negative. It's supposed to be 2 negative signs. These kinds of compounds have another name. It starts with an M. Does anyone know what is another name for a covalent compound? It starts with an M. In chemistry. It's like the big buzzword in science starts with an M that's not mitochondria. If you had to guess, what would you guess it to be? 8 letters. Starts with M. Really? Nobody's got guesses? Okay. Okay, so not everything in science is this word, or in chemistry rather, is this word. It gets thrown around a lot, but it means a very specific class of compound. A covalent compound, anything that is made from a non-metal non-metal sharing electrons, is called a molecule.
Oh my God.
You should feel bad about yourself if you didn't guess that. I'm kidding. A molecule. So sometimes these compounds are called molecular compounds. And this word molecule is another way to say I've got a negative and a negative. The ionic compounds are not molecules. These are. So, everything's here. We've said it all already. Now start filling in blanks. Covalent compounds are formed between negatives and negatives. Those negatives are nonmetals, and both nonmetals want to gain electrons. They have space in that outer valence shell. as you've seen with the Lewis diagrams and the Bohr diagrams that we've been doing, the negative electron or the negative ions have space to fill. So they end up, between them, they end up sharing. We have a particular set of rules for naming these things. Because they're sharing, it's not about balancing charges anymore. So we don't necessarily know how much of each is showing up based just on the charges. The ionics were easy. It was easy to say, okay, they're going to balance the charges, and it's going to be the lowest terms. So to balance out a 4 and a 2, I need one of those and 2 of those, for example. Or to balance a 2 and a 3, I need 3 of the 2s and 2 of the 3s, and then they're going to balance, they're going to be good. The covalents don't behave that way. And so to represent the fact that they don't behave that way, we've got special rules and prefixes that we use to denote how much of each is coming. So here are the rules. If I've got something like this, let's say I've got B2H4. This B is boron. Boron's on the right-hand side of the staircase. It's a nonmetal. Hydrogen, and again, I've said it before, I'll say it again, unless hydrogen is bonding with group 17, so fluorine, chlorine, bromine, iodine, astatine, assume that hydrogen is a nonmetal. So in this case, we've got 2 nonmetals, and these things are going to, we have to figure out what the name for this thing is. Here are the rules. In the formula, whatever element is listed first gets named first. And we just read it left to right like we would any English letter, any English word. So the left element is said first, and whatever is on the right is changed to IDE, where the right element is given the suffix "ide." At this point, it's not about metal, non-metal anymore. It's about whichever one's on the left and whichever one's on the right. Because covalent compounds share electrons, they do not balance charges. And so we use prefixes to tell us how many of each type of element are there to react. I have a list of prefixes. I will provide them to you. You do not need to memorize them, but for the sake of this, what are they? Before you do, don't flip it over, Muller. We've got a whole bunch of prefixes that mean different values numerically. We'll do the prefixes up to 10. Lots of them you are going to be familiar with already. If I have one of something, there are 2 prefixes that we use. We alternate between them. What are they? Sorry? Mono is one. If you have a set of glasses and you've only got one lens, that thing is called a monocle because it's got one lens, mono. If you're riding a bike and the bike only has one wheel, we call that thing a? It's not a bicycle because bi means 2. A unicycle. So the prefixes uni and mono both mean 1. In chemistry, we use the prefix mono. Bi is one of them that means 2, but there's another one. Tri is 3. Di is 2. It doesn't get thrown around very often, but this is the prefix we use for 2. So we've got mono, di, tri. What's the prefix for 4? There's 2 of them. Tetra is 1. It's the one we're probably least familiar with, but it's the one that gets used here. I mean, quad is the other one, but tetra is the one that we use in chemistry. 5 is penta, as in pentagon or pentagram if you're into horror movies. 8 is going to be octa, as in octopus or octagon. 6, 7, 9, and 10 are hexa. Oh, there's 2 for 7 that septa, or septa is not the one we use, but septa is the one that you're probably most familiar with. Believe it or not, my children are familiar with septa because they love Finding Dory, and Hank only has 7 legs. So they call them a septopus. But that's not the prefix that we use. The prefix for 7 we use is hepta. Nona is 9. And 10 is deca. So the two sets of prefixes, one is Greek, one is Latin. Honestly, I don't actually know which set we use, but this is it. Now, Muller figured it out. On the back side of the large periodic table I gave you are the prefixes. There's the chart. Mono, ditride, tetra, penta, hexa, hepta, octa, nona, deca. You do not have to memorize them, they're there. But again, not having to flip constantly to the back of your periodic table, I mean, it's not like these are hard to memorize, will save you time. The more you can commit to memory, the quicker things will go for you. So we use these prefixes to tell us how many of each are present. And there is a specific set of rules for these prefixes. The first element only gets a prefix if there's more than one. We do not use mono, ever, for the first element. We just don't. I don't know why. It would be easier to say if there's one, just use mono. But if the first one only has one, we don't use it. The second element always gets a prefix. Doesn't matter if there's 1, 2, or 10. And we do not reduce with the covalence. We just use them as they are. So, if we go ahead and take a look at this guy I give you up here, B2H4, the left element is said first. Okay, cool. So B is boron. And there's 2 of them. So because there's 2, we're going to go and find a prefix. The prefix for 2 means, or for 2 is di. So the name for this thing is going to be diboron. And then hydrogen gets changed to ide, so hydride. And I did not leave enough space there, because if I have 4 of them, I need to add what prefix? Tetra. So this thing could be called diboron tetrahydride, or I could have written this a different way. It's kind of arbitrary. We could call it B2H4, or we could have called this thing H4B2. There's no really good reason why boron came first. Hydrogen could have come first. If hydrogen comes first, what's the name for this thing? It would be tetrahydrogen diboride. It's however it's given to you, name it as written. The first one doesn't get it doesn't change to ide. It only gets a prefix if there's more than one. The second one changes to ide and always gets a prefix. So there's 2 more down here at the bottom. If I have Pi3, what's that thing going to be? What is P? It's phosphorus. There's only one, but because it's listed first, we do not use a prefix for it. This is just going to become phosphorus triiodide. And we do have a double I in there. The second one gets changed to ide. It gets a prefix, and it does have a double I. The next one's going to be what? It's going to be dinitrogen, because there's 2 nitrogens. Nitrogen's listed first. Tetraoxide. The AO is an acceptable vowel combination. I'm going to add 2 more down here. Let's go CO. One that you should be familiar with. C is carbon, and even though there's only one of it, we don't use a prefix on the first thing listed. O is O is oxygen, there's one of it, so it's monoxide. This one does not have a double O. No double O. To my knowledge, there's never a double O. Double I's are okay, double O's are not. Double O's would be monoxide, and that would be weird. Or monooxide, which is, I guess, kind of redundant. I don't know why they chose to double some vowels and not others. One more we're going to add down here just for funsies. Yeah, I didn't put it on the next page. H2O. More familiarly, H2O is water. But using these covalent naming, what is H2O? It's not hydrogen. It would be dihydrogen because there's two of them. Dihydrogen monoxide. And funny story, these naming rules are important. April Fool's Day, a bunch of years ago, two radio DJs in Australia, Sydney, Australia, got on and made this big announcement. The water has been contaminated with dihydrogen monoxide. Taken in large volumes, dihydrogen monoxide can kill you. You do not want to breathe it in. They made all things that are true of water, and they made this big deal about it. And they actually caused a nationwide panic. Both DJs were fired because people started bombarding their cities' municipal facilities with phone calls. Why? How could there be? And they actually caused a panic. Something as simple as just playing with chemistry naming, and both DJs were fired. So, important to know. Okay, naming's easy. Formula writing's even easier. We just use the prefixes as they're written to tell you how many of each element is present. If you can recognize that you've got a covalent compound, it's really quite easy. You want to be careful, though, when you're looking at these things, because unless you're really clear on what you've got, the prefixes can screw you up. When you're looking at the names, you first need to, when we're going to start mixing all these things together, you need to start deciding, do I have an ionic or do I have a covalent? And now that we've got the prefixes in here and the polyatomics in here, you can get screwed up. Because if you look, we've got monodi-tri, di is there, but di also shows up on the polyatomic list. Shows up as dichromate. So it's not just, you're not just looking for the prefixes now, you're looking for what the prefixes are combined with. Chromate's a metal. Dichromate is what we call Cr2O7. This is a polyatomic. It's going to create an ionic compound. Some students get confused because they're like, okay, bi also means two, like bicycle. And look, I've got a bicarbonate or a bisulfate or a bisulfide. These names in here I've also seen mess up students. It is about the prefixes, but it's also about identifying what those prefixes are attached to. You need to have a negative and a negative, or a non-metal. Once you can recognize that that's what you've got, there's no balancing, there's no reducing. You write it as written. If the first element has no prefix, there is only one of that element. And I'll go down here and I'll put a big star. No balancing. No reducing. C-I-N-G. No reducing for a covalent compound. So nitrogen trichloride. Nitrogen, non-metal. Chlorine, non-metal. This thing's covalent. I build it as written. Nitrogen doesn't have a prefix. So how many nitrogens do I have? There's no prefix. How many are there? One. I've got trichloride. So I've got Cl3. Thank you, Evelyn. And you're done. Sulfur hexafluoride. Sulfur, non-metal. Fluoride, non-metal. There's no prefix. There's only one. Hexa means I have how many? 6. And I've got fluorines, sulfur hexafluoride. If you can ever get your hands on sulfur hexafluoride, I'd highly recommend it. Sulfur hexafluoride does exactly the opposite to you that helium does. So if you've never breathed, hands up if you've ever breathed in a helium balloon. Makes your voice all awesome and squeaky. Okay? Sulfur hexafluoride does exactly the opposite. It drops your voice down. Makes you sound like this big, beefy, testosterone-loaded monster person. Mythbusters played with it. It's really quite cool. I'll show you a video if we have time. And then dinitrogen tetrasulfide is the last one. Di means I've got 2 nitrogens, so that's going to be N2. Tetrasulfide is S4. And because it's covalent, even though I have 2 of this and 4 of this, I do not reduce. The covalent compounds do not react in lowest terms. They react however the heck they want. And we just let them do their thing. Questions, comments, concerns? This is it. The naming is done. This block ends at early. Where is it? This block ends at 10:50. You got 20 minutes. Here's what I want you to do. This should be quick. Flip the page, find this. It looks like there's a lot. Technically, there's 40 questions there, but they tell you that everything here is covalent. And so really, you should be able to crank those things out really quick. That's not all. Because of what I'm going to get you to do. So these, they tell you, guys, these questions, A through T, here's the name, give me the formula. These questions down here, and they're all covalent. These ones down here are all covalent. Here's the formula, give me the name. I want you to flip over. This page here is optional. And if you flip one more time, this mixed ionic covalent compound naming, this one I want you to do as well. This guy is non-optional. This one puts it all together. There's some ionic, there's some covalent, they're all mixed together. It does not tell you what is what. You need to identify it and name it using the appropriate sets of rules. There they are. I want you to do all of those as well. So technically I'm giving you 60 questions to do, but the first 40 should take you 10 minutes. On your mark, get set, giver, and I'm going to queue up the sulfur hexafluoride video.